Alright, we're looking at GCO6. This video is dealing with worksheet number 1. The essence of this objective is all about things speaking about congruence. It's a word we've already begun using. We talked about congruent segments, or we've talked about congruent angles, things like that. So we're going to extend that a little bit to triangles and to general figures, but first of all, a word that gets used a fair bit in geometry, in definitions and in other places, is called rigid motions. Now, first of all, what are they? Well, rigid motions are ones that preserve the distances in the shape. They preserve the angles in the shape. They preserve parallelism, meaning things that once were parallel are still parallel, and so on. And you'll notice that we've actually already used a term for this thing as isometric. So first of all, I guess I would say to you, we're now learning a number of words that mean the same thing. Isometric transformations are the same as rigid motions. Now, we're going to define two shapes to be congruent if you are able to map one shape onto another using one or more isometric transformations. Or here we could have put rigid motions. So what it means is that if I can take a shape, say this one, and using a group of transformations, isometric ones, and if I can land it on another shape, they have to be congruent. In other words, if I can translate to here and then reflect it onto this one, these two shapes, this one over here and this one over here, must be congruent. So let's do a quick recap of the ones that are the isometric transformations or are the rigid motions. We've learned that a reflection is. We've learned that a rotation is. And we've learned that a translation is. Now we deal with ways to describe the relationship between the triangles or the quadrilaterals as a congruence statement. So what a congruent statement is a statement that relates one identical object to another and does it in a corresponding way. What I mean by that is if you tell me that quadrilateral A, B, C, D is congruent, this is our symbol for congruent, to MNOP, it's corresponding, meaning A corresponds to M in that quadrilateral, B corresponds to M, C corresponds to O, and D corresponds to P. So we'll show you what that means just shortly. Let's talk a little bit about this congruent symbol. There's actually two symbols in it. There's this little kind of squiggly guy here. That symbol basically means to have the same shape. So it is true that if we're congruent, we have the same shape. The equal sign basically says that we have the same size or the same measure. So to be congruent, you must have the same shape and the same size or same measurements. Now let's go back to this idea of corresponding parts. In other words, if quadrilateral ABC is congruent to quadrilateral MNOP, it means that angle A is the same as angle M. Angle B is the same as angle N. Angle C is the same as angle O. And finally, angle D is the same as angle P. So angles are preserved. Of course, we knew that because if we're doing rigid motions or isometric motions, angles are preserved. It's also true that lengths of sides are preserved. So the length AB, or that segment AB, will be identical to MN. See how I'm matching them up to their corresponding partners in the other group? So it is telling you that the order that you write a name in of a quadrilateral or of a triangle matters greatly. That's how we know who corresponds to who. So you can see my angles all match up and my sides all match up. So if you were asked to determine what the congruent sides and angles are for these two congruent triangles, it's pretty simple. You would know A matches up with H. You would know G matches up with J. You would know that R matches up with M. We would know that AG, that length of a side, that side would be congruent to HJ. That GR would be congruent to JM. And finally that RA would be congruent to MH. These things here are basically known as the corresponding parts of congruent triangles are congruent, or CPCTC. This is a short way of saying in a triangle set that are congruent, their corresponding parts all match up. I sometimes shorten that just like this to say the triangles are congruent to each other. Now let's just talk briefly about what it means. Again, this definition to be congruent. If I can map this guy onto this guy, then they're congruent. And sure enough, I can use a translation to slide it 6 over and 3 down. Therefore, they're congruent. Here, I can rotate this one onto the other. Let's show you that. And if I can do that, then they are congruent. If I can map it using a transformation that's isometric, then they are. And sure enough, when I do that, I get QRST mapped onto UVWX. Therefore, they are congruent. Here's another example here. It says, name a transformation or a sequence of transformations that would map one onto the other. So here I can see there would be a nice translation. Let's do that one first. I recognize its result there. So if I went 1, 2, 3, 4, 5, 6, if I translate 6 right, and 1, 2, 3 up, the shape A, B, C, D, I would land on this one. Onto L, let's see, I called it A, B, C, D, so it would be P, Y, R, L. Over here, looks like a rotation to me, so maybe I'm just going to verify that it is a rotation. Let's do a quick check here. Again, you see my patty paper coming out. Looks like a rotation of 90, 180. Ah, it's not. Let's take a look. That's interesting. So maybe, what do you think? What do you think? Maybe we have to reflect first and then translate. Bingo! Yeah, it said maybe we had to do more than one thing. So if we reflect first, we would get something that looks like this. Let me map it out. Okay, the first reflection would get us here. Alright. So I'm going to reflect in the x-axis our shape ABCD, and then I'm going to translate it over 6, 11, comma, -2. Notice again the order I wrote it in. I'm doing the reflection first and then the translation. Now that I'm done, I actually see I could have maybe reflected here first and then translated it down, but there's more than one answer. So now that we know what's going on here, we can now name this correctly. So A, that got reflected down here, let me label things so I can match them up nicely. If I called this one A, B, C, D, I need to call this one M, P, S, R would be the correct name. One last little reinforcement here. Same idea here. They're saying, can you describe a way to go from here to here to prove that they are indeed congruent? So the question is, are they congruent? And our answer is, if I can map this one onto this one, they are. And maybe for sake of speed, I'm going to just do it showing you using patty paper. But I think you'll know what to do here. I'm going to reflect this over the y-axis first, which would generate this here. And then my final description would be a translation to drop it onto here. So my answer is yes, they are. And specifically, it would be reflection over y and then a translation into that spot.